Welcome back, everyone, to our latest innovation pitch. And now we're going to be talking about robotics for agroecology by ROMI, which is basically robotics for microfarms, and Sony Computer Science Laboratories. And for this, we're joined remotely by Peter Hanappe. Peter, you're a researcher on all this. Can you hear me okay? And can you see us?
I can hear you, I can see you.
That's a good start. So why don't I just pass over to you and you tell us a little bit about ROMI and Sony first.
First, good morning, everyone, and thank you to the organizers of the FIRA for this event. So indeed, my name is Peter Hanappe, and I work at the Sony Computer Science Laboratories. We're situated in Paris. We're a fundamental research lab working on a variety of topics, one of which is sustainability, which is the team I'm working in. And that's basically what we're working on is basically what I'll be presenting today. So if you want to learn more about the CSL itself, Sony CSL, I would say take a look at our website. And so we've been participating in a European project called ROMI, Robotics for Microfarms, together with total 7 partners. There's a Fab Lab Barcelona, the CNRS, the INRIA, Châtelain Maraîchage, and also Humboldt University from Berlin, and France Europe Innovation. So it's a nice consortium, and again, I'll be presenting some of the works here today.
Terrific. So take it away.
Okay, thank you very much. So as you already mentioned, ROMI stands for Robotics for Microfarms, and as I also mentioned, the project really took off thanks to financing from the European Union. And we're working on 3 devices, really, concretely. The first one is the plant imager, which you see on the left. It's a device for collecting 3D data from plants. This can be real plants, but we can also work with virtual plants. The advantage of working with virtual plants is that it can be used, the data can be easily used for training AI and machine learning. And it's also a good way to test our analysis pipelines. This device, I would say, is mostly used currently for research, although our hope is that the technologies that we built with this project, with this device, will be able to be used in the field in outdoor conditions. The second device is the farmer's dashboard. It's a combination of an aerial device and a website. The aerial device is an alternative to drones. As we came into the situation ourselves where we were working at a farm close to the airport where it was absolutely forbidden to use drones. And so we started developing a cable bot. It's also very handy for use in polytunnels, for example. The idea is to collect data very regularly, and we have an online interface where we can trace individual plants over time and plot the growth curves of individual plants and the population of plants. So again, it's a technology brick that we plan to use in the long term. Then here you see the latest incarnation of the cable bot, and then here the latest version of the online interface. Then the last device is our rover for weeding, and I'll talk a bit more about that today. You can see here our prototyping version, our development version at our test farm. And it's a 4-wheeled robot, as you can see, and it combines both navigation and a precision weeding tool. So I'll first explain a little bit about the weeding tool. So the rover has a camera in the top. The rover drives forward, stops at some point, standing over the crops. It looks down, it sees the crops on the soil, as you can see in the left image. Then it uses an image segmentation algorithm to really detect the crops that have to be kept. This is the image in the center. Then it computes a path that will clean the soil using a rotary hoeing tool, and this tool will move along the soil, along the blue part that you see on the right image, to really clean the soil from any small weeds that might be there. If you do this once a week, we can keep the population of weeds under control. And maybe I can already say now that my colleague Doug will give a demo on Thursday. I think it's around 1:30, where you'll see videos of the tool in action. Now, I've presented this at the previous FIRA, this robot. What has changed since then is that we can now use plant discrimination. So we've used standard convolutional neural networks to really discriminate between the crops and the weeds. And this allows us to do more precise weeding, and also weeding when the weeds are slightly bigger than we could previously do. Then the second part is the navigation. This is also relatively new according to what I've presented in the past. We haven't worked much on navigation in the past, but we can now, the rover can now navigate autonomously along a bed of crops. And as I explain later, we try not to go too high end in the expenses of technology components. So what we try to do is use the camera for the navigation, the camera that's already in the rover. And we basically adapted a line following algorithm for the navigation, where we try to detect the crops and try to follow the crops and adjust navigation as necessary. So we measure an offset according to the center of the crops and orientation. And we can either use like the crops themselves, like in the left image, or when the crops get more dense, like in the right image, we can also follow the soil between the crops, between the lines. And this relatively simple algorithm has worked quite well for us now. So we will continue in that way using relatively low cost sensors. And there's still a fair amount of space for optimization, but we're really happy with how it's working in this first iteration. Now, some more concrete figures about the rover, a little bit like the ID card of the rover. Now, I'm not going to detail everything, but just to mention a couple of points, like we're aiming for an autonomy of 8 hours a day, and with the current battery that we have, and we think we can do it. We still have to do more detailed monitoring, and we still have some room for optimization, but it should be doable. Also, the weight is very low, actually, of the rover, about 140 kilograms, and this has some major advantages because we've seen on some of the tests that I mentioned that I'll show later that we can go in the field when the field is still completely wet, where other devices might actually get stuck. I think this is an important feature. Also, as you can see, we aim for a capacity of 5,000 square meters a week, or half a hectare. So this is, I guess, relatively small compared to the other devices that you might find. But our target is indeed smaller farms, as I'll come back to that later. Price-wise, we try to aim to make the robot really affordable. We don't have we're not at the end of the project yet. We don't have a completely defined price yet, but the price range that we set here is doable. So we went to the Accurate Challenge, which is organized by the Metrics project, and I would really advise everyone to take a look and participate in this challenge, because they've really done a fabulous job in trying to set up a protocol for testing reading robots. And we've been able to participate in all of the challenges: plant discrimination, plant destruction, navigation, infrarow reading. The reading was very challenging because the plants had grown a bit bigger than expected, but we came out, I think, very well. Of course, improvements are possible. So where are we now with the project? I think we have a sort of a first prototype with the functionality that we need to build a weeding rover. And our next phase is really to start working with farmers for evaluation and feedback. And then also to finalize the design on the hardware side. And we've already made significant progress in the testing and of the software. But of course, there's always work to do there. And of course, we'd like to bring it to the market at some point, probably as a form of a kit. But I think we will need another 3 years to really go through all the regulations and certifications. Now, the market that we're addressing, oh, this wasn't expected. Okay, I'll quickly skip to this one directly. Sorry about that. So we are, as I mentioned before, we're looking at smaller farms. We don't set a specific criteria, but I would say less than 5 hectares. And as you can see in Europe, there are about 10 million farms in Europe of that size. Now, if we really look at the farms that are specialized in vegetable farming and that have a significant reasonable income, then the market size in Europe would be roughly 50,000 farms, which is, I think, an acceptable market to get started with the project. Now, if you look worldwide, of course, 80% of all farms, which is over 500 million farms, are actually small farms, less than 2 hectares. Of course, many of these farms are subsistence farms with a low level of, say, technology. However, this may evolve over time. And they do produce approximately 1/3 of the world's food supply, according to the FAO. So it's an interesting target to look at. Now, one of the important aspects of our project, and I would like to sort of come to an end of this talk on this. Although we work on robotics and we love engineering the devices, our end goal is really sustainability. And sustainability is both environmental sustainability and social, economical, and cultural sustainability. And of course, it's a vast topic, and it's too short to go into detail here, but I would like to say a little word about this. So first, on the social and economical side, one of the sort of concepts that we use in the project is this notion of appropriate technology. I mean, this is not a new concept, of course. It's been around for, I would say, roughly 50 years. But it's the idea to have tools that are affordable, that you can build anywhere using locally sourced components, that the farmers or the users can be autonomous in repairing them, potentially building them. And it's generally taken to be low-tech technology, although I think currently that it's too restrictive, considering how the price of components have come down so much. It's so easy now to find embedded computers, to find cameras at very reasonable prices. We think that it's possible to build appropriate technology using off-the-shelf components. And so this is our position. And we also decided to make the project open source, open hardware, of course, to stimulate people building it, but also in a sense to stimulate communication between different actors and different farmers with, let's say, different backgrounds. So this is a part of the positioning also of the ROMI project. Now, in terms of sustainability on the environmental aspect, so I also wanted to mention this. We try to push the construction of, say, the rover even further, where we try to build the frame itself using very standard components and try to push it even more lightweight. and the advantage is that we can go to faster cycles of development, and potentially that we can ship the rover as a flat pack. So as I just said, coming back to the environmental sustainability, you may have seen images like the one on the left about agbots. It's not the type of sort of vision that actually inspires us. We're more interested about the farms on the right side. If we look at vegetable farming, some of the main environmental issues include biodiversity and soil health. And some of the proposed solutions are mixed intercropping, using perennials and wildflowers on the edges of the field, using soil cover, including living mulch, which is planting leguminous cover crops alongside the main crop. And so for us, the main challenge is how can you use these fantastic tools that AI and robotics represent to try to handle these more complex farming organizations, and how can you be efficient doing that? So question is, what will be the robot, or what will be the machine for the farm on the right side of this picture? And I think this still represents a tremendous challenge. So this roughly brings me to the end of the presentation. As you can see, we've made good progress with the ROMI project, and we have still exciting work ahead of us. And I'll repeat, so we'll have a demo of the rover more concretely on Thursday. So I'm open for any questions from the audience.
Any questions? Thanks, Peter. Any questions in the audience? Okay, while they're looking to see if there's any questions. Peter, I had one. I thought it was interesting when you said there were 500 million farms worldwide which cultivate less than 2 hectares. Does that mean you're actually more focusing on maybe developing farms on developing nations?
Well, not at this point, because we still have, say, a fair amount of work to finalize the technology, and it's really hard also for me to speak about the 500 million farms worldwide. I mean, there's such a variety of farms, but indeed, ideally, if we can contribute, then that would be indeed I would say a significant value for our project.
I have a question online from Martina Sabunia. How do you make the deployment of AI sustainable? Will the end user be able to create and deploy AI systems on the plants he wants to, or be limited to pre-made algorithms?
Well, very interesting question. Indeed, what we've seen is that when we say we work on a specific crop with a specific number of weeds, then we tend to train the network for, say, that field we'll fine-tune the network for that field. And indeed, it would be an interesting challenge to see how there could be like a participative way to share those training sets and weights of the network. So this is currently not part of the ROMI project itself, but I think there would be an interesting community project about sharing that data.
Terrific. I know you're going to be around over the next few days. Any more questions, you'll be able to handle those. And again, you said there's a demo coming up where we can see this on Thursday, I think you said. So we're looking forward to that. And you'll be taking more questions online if you have them. Yeah, go ahead.
Yeah, well, I think there are 2 questions that came through the FIRA website.
But we're running out of time, though. That's the problem. So can you answer them online? And there'll be more questions coming to you that way. So, and I do recommend people go to your website to have a look, because it's really interesting about these robots for microfarms. Really interesting stuff. So, Peter, thanks very much. We'll be seeing your demo later in the week. So, appreciation.
Thank you very much. Have a good day.
So, if you like wine, then stick